Imagine you're floating 400 kilometers above Earth's surface. No air to breathe, no natural fuel, and everything that keeps you alive has to be rocketed up from Earth. Sounds impossible, right? But what if you could make your own oxygen, and even your own fuel, right there in space? Well, China just took a massive leap toward making that a reality, and it's got the whole world watching. Welcome to a new era of space innovation. China's Tiangong space station just pulled off something that could change everything about space travel. A successful photosynthesis experiment in orbit. We're not talking about growing plants in space. No, this is artificial photosynthesis, engineered chemistry that can turn carbon dioxide and water into oxygen and fuel, at room temperature using minimal energy. Let that sink in. This isn't science fiction. This is happening right now. And even NASA and Elon Musk are paying attention. Here's what you need to know. On July 14, 2025, China launched a resupply mission to Tiangong using its Tianzhu 9 cargo spacecraft and the reliable Long March 7 rocket. The mission included over 7 tons of cargo, food, lab supplies, and equipment for the crew of Shenzhou 20. But hidden among those supplies was something far more significant. A set of chemical catalysts for testing a new system of artificial photosynthesis in space. This wasn't just an experiment, it was a declaration. So how does it work? Think of this system as a high-tech miniature forest. But instead of plants, it uses specialized catalysts, materials engineered to mimic the natural processes of photosynthesis. These catalysts pull in carbon dioxide, add water, and using sunlight, they produce 2 valuable outputs: oxygen for breathing and ethylene, a flammable gas that can be refined into rocket fuel. And here's the game changer. It does this at room temperature, under normal pressure conditions without the need for massive energy input. That's a huge improvement over current systems. Right now, the ISS uses electrolysis to create oxygen, splitting water molecules with electricity. But that method consumes about 1/3 of the space station's entire power supply. That's not sustainable for long missions like those going to the Moon or Mars. China's new method? It uses far less energy and it's modular, adaptable, and efficient in microgravity. It's not just a step forward, it's a leap. This artificial photosynthesis technology has the potential to reshape long-term space missions. Imagine future astronauts traveling for months or even years without needing constant resupply missions from Earth. Instead, they produce oxygen and fuel right on board. That means lower costs, greater autonomy, and a realistic path to permanent bases on the Moon, Mars, and beyond. Elon Musk's vision of colonizing Mars? This is the kind of tech that makes it possible. But let's dig deeper. What makes this tech so revolutionary is its flexibility. By tweaking the chemical pathways, these catalysts can also produce other valuable compounds like formic acid, which can be used to make sugars, or methane, a high-efficiency rocket fuel. In simple terms, it's like carrying a self-sustaining chemical lab with you wherever you go. No heavy tanks of gas, no constant supply shipments, just smart chemistry working with what's already around you. Even more impressive? It works in microgravity. That's a critical detail. Chemical reactions behave differently in space. Liquids don't mix the same way, gases don't separate as easily, and catalysts can lose effectiveness. But China's system is designed to overcome those challenges, performing reliably even in orbit. That makes it scalable, not just for Tiangong but for lunar outposts, Mars habitats, and deep space missions. China isn't just building tech, it's building long-term strategy. While NASA's International Space Station nears the end of its operational life, scheduled for retirement around 2030, China is expanding its Tiangong station. Currently made up of 3 modules, it's planned to grow to 6, doubling its capacity and capability. That would make Tiangong the world's most advanced operational space station, and with innovations like artificial photosynthesis on board, it could also be the most self-sufficient. But this isn't just about winning a race. It's about redefining what space travel even means. For over 60 years, every astronaut has relied on constant support from Earth. Oxygen, fuel, food, it all had to be launched up, piece by piece, mission by mission. But with this breakthrough, China is showing the world that self-reliant space ecosystems are no longer a dream. They're within reach. And that could shift the balance of global space leadership. Scientists around the world are watching this closely. Katharina Brinker, a catalysis expert from the University of Bremen, says this could revolutionize life support systems in space. Why? Because if you can create oxygen, fuel, and even food precursors on demand, it transforms mission planning. Space becomes more than a destination. It becomes a domain we can live in. Think about the implications. Fewer rockets from Earth. Lower costs. longer missions, and maybe, one day, permanent settlements beyond our planet. It's no surprise Elon Musk and SpaceX are likely watching this with interest. Musk's vision of a Mars colony depends on solving exactly these challenges. How do you survive and thrive without constant support from Earth? Artificial photosynthesis might be one of the critical pieces of that puzzle. Now let's be real. This is early-stage tech. We're still in the testing phase. But the success of these experiments aboard Tiangong is a strong signal that China is not only serious about space, but years ahead in developing the infrastructure for sustainable, long-duration missions. And that's something no one, not NASA, not SpaceX, can afford to ignore. Whether you're a fan of space science, a student dreaming of working at NASA, or just someone fascinated by the race for the stars, this breakthrough is one you'll want to remember. It shows us what's possible when ambition, innovation, and smart science come together. China isn't just participating in the new space age. It's aiming to lead it. And here's the motivation behind it all. Space exploration isn't just about flags and glory anymore. It's about survival, progress, and our future as a species. If we want to go further, if we want to stay longer, if we want to truly explore the cosmos, we need technology like this. We need to think differently, build smarter, and stop depending on Earth as our only lifeline. Because the next great frontier isn't coming. It's already here. If you found this fascinating, you're not alone. Share this video with someone who's passionate about space. Leave a comment and let us know what part of this breakthrough excites you the most. And of course, if you want to stay updated on cutting-edge tech, space missions, and the future of humanity beyond Earth, hit that like button, subscribe to Alpha Tech, and ring the notification bell. We've got more epic stories on the horizon. China's big leap in space exploration has sparked a global conversation, but the story isn't as one-sided as it seems. While the experiment aboard the Tiangong space station is undeniably groundbreaking, showing that artificial photosynthesis could one day sustain astronauts by generating oxygen and fuel, the reality is far more complex. Despite the excitement, China's new tech still faces major limitations that can't be ignored. Let's start with scale. The artificial photosynthesis unit developed by Chinese scientists uses semiconductor catalysts housed in compact, drawer-like units aboard the Tiangong space station. But space aboard any orbital station is extremely limited. The usable surface area inside modules like Wenyan is only about 17 square meters. That restricts how much CO2 and water can be processed in any single cycle. As a result, the oxygen and ethylene outputs are still relatively low, nowhere near the levels needed to support a full crew's continuous oxygen demand or generate significant quantities of fuel. To put this in perspective, consider that humans require a constant oxygen supply to survive. Generating just one astronaut's daily oxygen needs, around 0.84 kilograms, would require converting large amounts of carbon dioxide efficiently and continuously. At the current rate, the prototype system on Tiangong is far from achieving this. It's a small-scale test, not yet capable of delivering life support for long-duration space missions or powering spacecraft with in-orbit fuel production. Second, let's talk microgravity. Semiconductor catalysts like nitrides rely on sunlight and consistent exposure to both CO2 and water to perform reactions efficiently. But in a microgravity environment, fluid and gas dynamics change completely. Liquids and gases don't flow the same way they do on Earth. Instead, they tend to clump or form bubbles, which leads to uneven distribution inside the device. This disrupts the consistency of chemical reactions, reducing efficiency. Although China has reportedly conducted at least 12 microgravity experiments to address this challenge aboard Tiangong, the lack of publicly available data makes it difficult to assess how well the system is working. We still don't know the actual conversion efficiency, how much CO2 is truly being turned into ethylene or oxygen. On Earth, some artificial photosynthesis systems report efficiencies below 1%. If China's space-based system is operating at a similar level, then it's far too low to replace existing life support technologies like electrolysis used aboard the ISS. Now about the fuel. Ethylene, while technically a flammable hydrocarbon, isn't widely used as rocket fuel. It's less energy-dense than RP-1 kerosene or methane, and storing it is trickier. For it to become a viable fuel source for propulsion, ethylene must be further converted into other compounds, typically methane, through hydrogenation. That process requires the presence of hydrogen, additional catalytic hardware, more energy, and more space. But producing hydrogen in space is no easy feat. You'd either need water electrolysis, which again consumes significant power, or you'd have to transport hydrogen from Earth, defeating the whole purpose of in situ resource utilization. Integrating such complex chemical pathways into a tight space like the Tiangong modules would be extremely difficult without major system upgrades or additional space infrastructure. So where does that leave us? The reality is this: producing oxygen and fuel directly in orbit is technically possible, but only on a very limited, experimental scale for now. The output from this system can't yet replace existing life support tech or generate fuel at the quantities needed for interplanetary travel. However, the fact that this artificial photosynthesis technology works at all in space, even partially, is a huge step forward. What China has done is build a foundation. They're testing key principles that could eventually lead to larger, more advanced life support systems or orbital fuel plants. And even if this isn't enough to immediately overtake NASA or SpaceX, it shows the long game China is playing. Space isn't a sprint, it's a marathon. And every experimental success, no matter how small, helps move the needle forward. Meanwhile, SpaceX is far from sitting still. In fact, just yesterday Elon Musk stirred major excitement by tweeting, "Shortly before the next flight, I will do a live technical update on Starship, going over progress to date and engineering, production, launch plans for the future." That means another big reveal could be right around the corner. Musk is known for using these live streams to energize his base and share crucial milestones. Everything from heat shield improvements to Starship Block 3 enhancements. It's a chance to showcase SpaceX's momentum and reassure both fans and stakeholders that they remain on track for Mars. Beyond the tech, there's politics. The relationship between Elon Musk and Donald Trump remains complicated, with both collaboration and conflict shaping the narrative. Recently, reports surfaced that the Trump administration is considering an executive order to roll back environmental regulations for commercial rocket launches. This would empower the Department of Transportation to expedite launch licensing by reducing environmental impact assessments. If passed, the executive order could accelerate launch schedules for companies like SpaceX by cutting through the red tape that Musk has long complained about. Launch delays due to FAA restrictions have been a persistent thorn in SpaceX's side. A deregulated path forward would mean more launches, more testing, and faster deployment of Starlink and Starship missions. But just when things seemed to be aligning for Musk, another unexpected twist emerged. On July 22, the Trump administration unveiled a plan to expand development of the Golden Dome Missile Defense Initiative. Modeled after Israel's Iron Dome but on a massive scale, this U.S. version would protect against advanced threats like hypersonic weapons and ballistic missiles. The proposed system would require an expansive satellite network, potentially 400 to over 1,000 satellites for early threat detection and real-time interception. SpaceX had been in the lead, proposing a joint venture with Palantir and Anduril to provide launch capabilities and build key elements of the satellite system. But Trump's expanded search for partners has introduced new competitors, including Amazon's Project Kuiper and traditional defense giants like Raytheon and Lockheed Martin. With the stakes raised, SpaceX's hold on the contract now looks less certain. Despite that, SpaceX's credentials are unmatched. They've launched over 9,000 Starlink satellites, built reusable rocket platforms that have transformed economics in space, and proven themselves in both civilian and military missions. If there's a company capable of supporting a large-scale missile defense system from space, it's SpaceX. But competition is fierce, and the political landscape is shifting quickly. So what's next? China's artificial photosynthesis tech shows promise, but it's not ready for prime time. The US still leads in deep space capabilities, reusable launch systems, and moon missions. But the gap is narrowing and every move counts. Whether it's a chemical experiment aboard Tiangong or a live stream from Starbase, the future of space is unfolding in real time. If you're as fascinated by these space breakthroughs as we are, don't forget to like this video, share it with your space-obsessed friends, and subscribe to Alpha Tech. We're closing in on 150,000 subscribers, and every single one of you helps us keep creating thoughtful, future-focused content. We'll be tracking the next phase of China's Tiangong experiments, SpaceX's Starship updates, and what Elon Musk reveals next. Stay tuned because the new space race isn't slowing down, and neither are we.